College Algebra, Topic 6.2, Solving Nonlinear Systems. Number 3, our nonlinear system is x plus y equals 3, y plus z equals negative 6, and x plus z equals 1. This system has three variables, x's, y's, and z's, and typically the number of variables that you have also will relate to the number of equations you'll have. So we have three equations for the three variables. I'm going to use the elimination and eliminate one of the variables. Let's say the y's. I have a positive y here, so I want this to be a negative y, so we go with cancellation. So I'll multiply this by negative 1. When I do that, we're going to get a negative, let's put it here, a negative y, a negative z, and a positive 6. Well, together with the x plus y equals 3, we will combine those. The y's will cancel because one is positive, one is negative, and we're left with a positive x, a negative z. And the 3 and the 6 become 9. Now, for the third one, we don't have to eliminate any y's because there are no y's in this, so that's a problem that we don't have to work on. We just simply pull it over. And now we look to eliminate another variable. Let's see, we have a negative z and a positive z. Well, those will cancel. So let's cancel those. So 2 x's, the z's cancel, and 9 and 1 make 10. I solve for x, we get x equals 5. Now, since we know that x equals 5, we can put 5 back here and have 5 plus y equals 3 and solve for y. Subtracting 5 from both sides, we'll get y equals negative 2. And we can also solve for z here by putting x is 5 here. So 5 plus z equals 1. And subtract 5 from both sides, and I get z equals negative 4. So the solution of my system will be x is 5, y is negative 2, and z is negative 4. Okay, next linear system. Let's see. This is also from the set. That was number 3. This system is a system of two variables, x, y equals 8, and 3x plus 2y equals negative 16. So this is basically a, let's see, this is the inverse function right here, and this is a linear equation. We're going to solve this one this time by using substitution. Now, instead of trying to solve for a y or x, I'm going to leave the y and the x together and try to create a yx down here for substitution. So let's do this. Let's say 3x plus 2y equals negative 16, and I'm going to multiply this whole thing by x. This will give me 3x squared plus 2xy equals negative 16x. And there's my xy right here for substitution. I can replace that with an 8. So 3x squared plus 2 times 8 is going to equal negative 16x. The 2 times 8 will become 16. Then I pull my negative 16x to the other side as a positive 16x, and it'll become positive 16x plus a 16, all set equal to 0. And now I have a quadratic that I can solve by factoring. So I'm going to factor this into two binomials. 3x squared can break up into 3x times x, and I'll choose to break up 16 as 4 times 4. Now to see if this really works, I'm going to put in my inside, multiply my inside and my outside, 3x times 4, which is 12x, and I see that if these are both positive, we will get the positive 16. So I'll make sure these are both positive. Now we have 3x plus 4. This factor is set equal to 0. And the other factor, x plus 4, is also set equal to 0. When I solve this one, we'll get 3x equals negative 4. And finally, x equals negative 4 over 3. And when we solve this one, we'll get x equals negative 4. So we have two potential solutions. So let's go back up and put negative 4/3 in for this x here on top. So negative 4/3 times y equals 8. And to solve for y, we'll get rid of the denominator by multiplying by 3, the denominator. They'll cancel. We'll get negative 4y equals 24. Then I'll divide everything by negative 4. And we'll finally get y equals negative 6. So that implies that this point will be negative 4, 3, and a negative 6. And let's go back and put x is negative 4 into xy equals 8. We'll then get negative 4y equals 8. And we'll divide by negative 4 on both sides. And y will equal negative 2. So the next point will be negative 4 comma negative 2.